Welcome back to Java Internals Crashcasts. I'm your host, Sheila, and today we're diving into another fascinating topic in our Synchronization Utilities season. We're currently in the Advanced Synchronization Techniques chapter, and we'll be exploring StampedLock. Victor, are you ready to stamp out some confusion?
Absolutely, Sheila. I'm excited to break down this powerful synchronization tool for our listeners. Before we start, listeners should be familiar with basic threading concepts and have some understanding of locks in Java.
Great point, Victor. Now, let's kick things off with a quiz question for our listeners. Here's a tricky one. What unique feature does StampedLock offer that sets it apart from traditional read-write locks?
Ooh, that's a good one, Sheila. It really gets to the heart of what makes StampedLock special. Listeners, take a moment to think about it. Consider what limitations you might have encountered with other lock types and how a new lock might address those. We'll reveal the answer at the end of the episode, so stay tuned.
All right, Victor, let's start with the basics. What exactly is a StampedLock, and why was it introduced?
Great question, Sheila. StampedLock was introduced in Java 8 as part of the java.util.concurrent package. It's a special kind of lock with 3 modes for controlling read-write access to a resource: writing, reading, and something called optimistic reading. The main goal was to improve performance over previous locks in situations where readers significantly outnumber writers.
That's interesting. So it's like an upgrade to previous locks. Can you explain how it differs?
Certainly. While both manage read-write access, StampedLock introduces a new concept called optimistic reading. This mode allows a thread to read without acquiring a lock, which can significantly improve performance in read-heavy scenarios. However, it's important to note that StampedLock doesn't allow the same thread to acquire the lock multiple times like some other locks do.
Optimistic reading sounds intriguing. How does that work in practice?
Think of optimistic reading like checking out a book from a library without signing it out. You can start reading right away, but you need to verify that the book hasn't been changed or removed before you finish. In programming terms, you'd use a method to start reading, read your data, and then use another method to check if the data has been modified by a writer.
That's a great analogy. So what happens if the data has been modified during an optimistic read?
If the data has been modified, the check will fail. In this case, you typically fall back to a regular read lock to ensure data consistency. It's a trade-off between speed and guaranteed consistency.
I see. Can you walk us through the other lock modes available in StampedLock?
Of course. Besides optimistic read, StampedLock offers write lock and read lock modes. The write lock is exclusive, meaning only one thread can hold it at a time. The read lock can be held by multiple threads simultaneously, but it prevents any thread from acquiring a write lock. These modes are similar to traditional read-write locks.
That makes sense. Now, you mentioned earlier that StampedLock can offer performance benefits. Can you elaborate on that?
Absolutely. The key performance benefit comes from the optimistic read mode. In scenarios where reads are very common and writes are rare, optimistic reading can dramatically reduce contention and improve throughput. However, it's important to note that these performance gains come at the cost of increased complexity and the potential for a problem called livelock in certain scenarios.
Livelock? That sounds dangerous. Can you explain what that is and how it might occur with StampedLock?
Great question, Sheila. Livelock is a situation where threads are actively trying to do work, but they keep getting in each other's way, preventing progress. With StampedLock, this can occur if many threads are continuously failing optimistic reads and immediately retrying, potentially starving writers. To avoid this, it's crucial to use StampedLock correctly and consider fallback strategies.
That's really important to know. Are there any best practices or tips you can share for using StampedLock effectively?
Absolutely. Here are a few key points. 1. Always release locks in a finally block to ensure they're released even if an error occurs. 2. Be cautious with optimistic read mode. It's great for performance but can lead to livelock if overused. 3. Consider using a special method when upgrading from a read to a write lock, as it's often more efficient than releasing and reacquiring locks. 4. Remember, StampedLock doesn't allow the same thread to acquire the lock multiple times, so be careful not to cause deadlocks. 5. Use StampedLock for its performance benefits, but don't replace every lock in your code. Assess each use case individually.
Those are excellent tips, Victor. Now, can you give us an example of where StampedLock might be used in a real-world scenario?
Certainly. Imagine a high-traffic website that displays real-time stock prices. The prices are updated infrequently, writes, but read very frequently by users. StampedLock could be used to manage access to this data. Most of the time, readers would use optimistic read mode to quickly access the prices without locking. When an update comes in, it would use a write lock to update the prices. This setup could significantly improve the website's performance compared to a traditional read-write lock.
That's a great example, Victor. Now, before we wrap up, let's reveal the answer to our quiz question. What unique feature does StampedLock offer that sets it apart from traditional read-write locks?
The answer is its optimistic read mode. This feature allows for non-blocking reads, which can significantly improve performance in read-heavy scenarios. It's what truly sets StampedLock apart from its predecessors.
Excellent. To summarize today's episode, 1. StampedLock is an advanced lock introduced in Java 8 for managing read-write access to resources. 2. It offers 3 modes: write, read, and optimistic read. 3. The optimistic read mode can provide significant performance benefits in read-heavy scenarios. 4. StampedLock doesn't allow multiple lock acquisitions by the same thread and requires careful use to avoid issues like livelock. 5. Best practices include proper lock management, cautious use of optimistic reads, and appropriate use cases. Victor, any final thoughts?
Just remember, StampedLock is a powerful tool, but with great power comes great responsibility. Use it wisely, and it can significantly boost your application's performance.
Thank you, Victor, for these insights. In our next episode, we'll be discussing thread local, another fascinating concept in Java concurrency. Don't forget to subscribe to Java Internals Crashcasts and leave us a rating if you enjoyed this episode. Until next time, happy coding.